2016, Leaving Cert Higher Level Paper 2, Question 1 is a coordinate geometry question. Part 1 is equation of a line, and Part 2 is orthocenter. So in Part 1 you're asked to find the equation of the line through B, which is perpendicular to AC, so approximately something like this. From the vertex to the opposite side, which is setting up the second part of the question, this is an altitude, and where the altitudes intersect, we have the orthocenter. So the equation of the line through B, well, it's through the point B, which is 5, 3. So we need the slope of this line. So we can get the slope of AC, invert it and change the sign, and we've got the slope of B, whatever you call this point. So AC, if we write our points down, 6 minus 2 and 3, 4. So the slope we can see is negative. So the change in Y is 6, and the change in X to minus 3 is 9. So we have 2 over 3, or minus 2 over 3. So the perpendicular slope is equal to 3 over 2. So now we have our point B and we have our slope, 3 over 2. Y minus y1 is the equation of a line, times m equals m times x minus x1. Fill your values in. Y minus 3 is equal to 3 over 2 times x minus 5, and just tidy it up. 2y minus 6 is equal to 3x minus 15, so 3x minus 2y equals minus 6 plus 15, which is 9. So we need to use our answer to part A to find the coordinates of the orthocenter. So obviously these questions are easy when you know what the orthocenter is. So let me continue this line along here. And the point A, we create a right angle with that line. It looks like it's about approximately, now there's only an approximation, approximately there. So the orthocenter is the intersection of these altitudes. Squaring off a bit. So if I continue this altitude up this way, it's approximately up here somewhere. And if we do the same thing, that's A to CB, we could also do C to AB. So we continue the line AB along, and we draw a line from C perpendicular to that line, approximately there. This is my approximation for the orthocenter. So we can use either of the lines. If we get the slope of this line here, CB, and then invert it, change the sign, we have the perpendicular slope of this line that's going from A through the line BC. So let's write the points B and C down. 5, 3 and minus 3, 4. 5, 3, minus 3, 4. And you can see it's a negative slope. It's an airplane coming into land. Negative slope. So the slope, this slope is equal to minus the change in Y, which is 1, over the change in X, which is 8. So the perpendicular slope is equal to 8 over 1, or 8. And my point A from above is 6 minus 2. And then we need to get the point of intersection of the two lines, the one we got in part 1 and the one we got in part 2. So again, it's always good maths to write your formula out. Y minus y1, m times x minus x1. Y minus minus 2 plus 2 is equal to 8 times x minus 6. So we get y plus 2 is equal to 8x minus 48. So 8x minus y is equal to 50. And if I multiply this by minus 2, or bring this line down to meet it, I think it's easy to multiply this one by minus 2, or just multiply it by 2 and change the signs of the first one, but we'll get minus 16x. We'll have to change our signs back. Plus 2y is equal to minus 100. That's this line by minus 2. And then we have 3x minus 2y is equal to 9. So we're going to get, when you can see it's a minus 13x minus 91, so we're going to get 13x equals 91 and 7 13s are 91. So x is equal to 7. So y, the easiest equation to use, well, we could use this one here. Y is equal to 8x minus 50. If you bring the y to the right and the 50 to the left, y is equal to 8x minus 50. Y is equal to 8 7s or 56 minus 50. So y is equal to 6. So your point of intersection, which is the orthocenter, 7 for x, 6 for y, is the orthocenter. And my estimation was way off, but I was just trying to make the diagram as big as possible. So 7 6 will be approximately somewhere here. So well, way off. Well, it is pretty way off, but you can see what we're trying to set up here, the orthocenter question. So one of the questions they can ask, can the orthocenter be outside the triangle? And you can see from this question, 2016, that the orthocenter is outside the triangle itself.